maybe Cairo as well. Turn everything on. That's floating. It's not that bad, it stopped. Okay, actually I have another question. Why is 18 drawn like this? I mean, the label is above it. I can imagine that what that means. I think 18 is like somewhere here on the left. The cubic between 18 and 19 has a maximum here. Now we zoomed in so ridiculously far that the maximum looks like a straight line. I think I just should use not the green color here, something else so I can recognize that it is not really a sample. I'm pretty sure we don't have a sample at this point. I think the last one is 19 here. That's a lot of Cairo stuff. Holy moly. No, can't find this. I'm looking for all those dashes. This is the one at 7.7745. That would be 19, yeah. So 19 is the last one. So you can see that this is 19. It's more Cairo than anything else. Notice. Yeah, and 18 is outside the window. I think I'm going to turn off Cairo again. Notices. think this is the 18 that is being drawn. I should set restart on as well. They get drawn at the same time. So I think that at the moment we draw 19, we find out that there is a cubic between 18, which is here, and 19, which is the maximum at this point. And then handle local extreme is being called. That would probably the last time we call this. And that does draw 18 at some point. I thought it was shortly after that point. Yeah, Geo show text. Drawing 18 in that position. That must be it, because this is inside the window. It's the second time the layer region draw is being called. And of course I've got to $49. Hello. Text. Create text. Sounds like a user call. Yes. Yep, that's it. Well, that was a long-winded way to find it, but I'm just doing send it above. I should do something change the style a little bit so I can disambiguate it from, or just really recognize that it is not a normal sample. Point style. Let's use choose a diamond. No, let's use a triangle. Triangle down. Field shape. I think I need something like no, this one, fold. Triangle down false. So false is that it is not filled. And then you have to specify the index into this array. That is 0, 1, 2, 3, 4, 5, 6, 7. And then the thing is probably called field shape. Go color index is first, and then we get field shape. I think I want to change the color too, or is that not necessary? No, not really necessary, I guess. No, I forgot the number. 46. Yeah. Dat was een echo. Next probe 7.7745. 7745. That is a green arrow. So now we get 19. It was not this one, it's the next one. It's derivative. This is 47. There's 19. Insert it into the chain. Initialize node. Is that going to do the whole thing or not? Not sure. Initialize cubic. Looks like it did draw something, which is not visible. Yes, I am. I'm slightly confused though. Thought it would have been drawing that 18 like ages ago. So just stepping and nothing happens basically. Just set a breakpoint and local extreme. Seven 7.77478. 478. 77478. It's this dotted line here. It does not make any sense. Nothing. But chain lost. 2. $19 is the last one. Still. Left neighbor. Okay. No, that doesn't look like a triangle to me. It made it a filled square. What? I should have done 7. It was 7. Why does it say 8? What nonsense is this? 7. Yeah, filled rectangle. I wanted to use 7. Is that 7? I typed 8. Okay, for the rest that doesn't matter. Yeah, okay, so what this is really about is that continue. Oh, I'm not continuing. Just continue. It's totally not continuing. Delete everything. Continue. So it is fitting cubic through 19. Cubic is visible. And no, it's not visible. What the heck? Why? I think there should be a cubic now going like up, having a maximum in 19 and then going down and have a minimum in this new point here. And that cubic has vanished. And the question is why? Okay, let's quit. Well, what is the last restart? 75. But anyway, yes. So 74. That is too far in the sense that, oh, it looks like it is being drawn here, maybe. Yeah, it should go through 19. Anyway, it did go too far, I think, because it definitely passed the point where it is drawn. I even want to see how the code looks like where it draws it, when it still draws it. Damn, let's try, I don't know, 72. Yep, so now 72 already did draw this cubic. Would be nice if I knew where exactly that happened. I don't know. Let's try one less. See what it 71. Probably not one then. It's another, something else is being drawn here. Not a color anyway. Yeah. This is 71, and I want to know where the thing is being drawn. There. Okay, so that was in handle extreme jump. So we do the rerun again. Break handle extreme jump, continue. And I think that if now I do continue, it will draw it. Just to be sure, yep. So rerun it again. Continue. And now we do next again until it is drawn. That was it. Well, that's literally triggering an event to draw it. So this is then apparently it. 246. In what file? Algorithm.h. Yep, in handle extreme jump. So I can put a breakpoint here, and then we have already, that was already printed. It is 239. thread 1. What breakpoint is this? 13. Oh, what? Okay, now we're in 239. So we just printed that it is going to draw this cubic. Note that this cubic has a critical point at 7.776. 77657. That's probably the minimum on this side, all the way outside the, I don't know, here maybe. Yeah, inflection point should be visible. Is that also printed here? Inflection point 7.77555. 7.77555. That's here. Yeah. Looks indeed like the point where the curvature is changing. Okay. Now if we do continue, then we get here again. I mean, this one is, I did continue. Now it did draw it. I have to press space. And now we're on 239 again. And now it should be drawing something which it isn't. But it should happen here, I think. That's right. And it printed that it is doing this one with a critical point in 7.77555. Which is, no, maybe here. And the inflection point should be halfway. So halfway here. 775. I don't know, 7750 something. Yep, 7750 something. So that looks good. It looks like it is sane as well, and yet it is not being drawn. Why not? Okay, this is pretty difficult to get back to. Oh, we have a restart count just in front of it, 74. Just test it. No, I'll just continue. Now we are in this function again, in the extreme jump. What a huge jump. Not really, but it did change. And now we do a trigger which should do an event, a cubic polynomial event. Yeah, I have no clue how to even check this. I think I can do step. That's inside trigger. No, I have no idea. We'll get back in our own code. Yeah, there we are. Algorithm event callback. Yep. So this is the cubic that we are going to plot. Yeah, must be correct. It's calling solve. Not even sure what that does anymore. Kind of wonder for which W village this is being called. Maybe set a breakpoint in this call here. So that would be the operator parenthesis of a double. No, of a wait ref, I think. No, it's a double. Not defined. Bullshit. Oh, const. De. Continue. Well, it's being called for 7.7734. So that's just the window size. 7734. It's the first time. And then at the end it's 7.775 something. Now surely this is calculatable, right? I mean, coefficients are not small, but you can calculate this. Perfectly fine, no problem. But minus 2808 is very negative, but not like so negative that you get all kinds of overflows, right? So it's supposed to be a cubic that there's a minimum here and a maximum there, and then go down. And then by the time we are here, it's at minus 2800. So that's, I don't know, four window heights down. Nothing special. So you do continue, then we're being called with 7.745. Where is that? 7.7745. It's in the middle of the window. So that should be have a distinct, have a value like between 0 and 600. Yes. 540, that's like the maximum. Now we do continue again. Now it's called with 7.7756. That is the end of the window here. At which point it can also be evaluated, of course. .5, so almost 0, but already going up again. So yeah, I don't see any problem with the evaluation, so let's not continue, otherwise we lose it. Or maybe do continue, but have a breakpoint here. And a breakpoint at 237. And then continue to see how often this is called. It's called for 7735. 7739, 7750. So it's evaluating the cubic often enough to be able to approximate it with a lot of Bezier functions down to an insane precision. And so on. I don't think this is a problem. Though we do have a lot of them, so you're going to have a lot of Bezier functions, Bezier curves. These are insanely small steps, so. Maybe you do get maybe you do get floating point round-off errors. So much even that it hardly looks like a smooth function anymore. So it can't manage to find any Bezier curves. This is really, come on, it's only changing here. It's like less than a pixel. Way less than a pixel. But it does not make much sense. So why is it doing this? 0.24. Delete that one. Continue. Here we do get this reach max depth, so something is going wrong. Now it's going to try to plot this thing. I guess this is still 1. Vector of length 0. Okay, that's why we don't see anything. Yeah, so it is the solve that goes wrong then. Interesting. Cubic curve. Okay, so there's a problem in solve. How do I get there again? Let's delete. Now let's add a breakpoint at 235. And then just do a rerun. And continue. Oh boy, that's not the line that I added breakpoint in. It's the handle extreme jump. I should have deleted 17. Yeah, this is the call back. Here we enter solve eventually. Viewport. Back at 2, 3, solve. We're entered solve. And then the first thing you do is call solve again. And the new solve. And so that clears result, and then call solve again, and again another solve. That's a tolerance to 100 thousandths of the viewport height. And then we call the thing that probably wants tolerance reset. T0 and T6. It's doing a Chebyshev fit. So these are just the begin and end of the window. The visible part. And then we call solve again. Also calls func on T0 and on the half. Yeah, that's what we saw. So we saw this call at the beginning of the window and then halfway the window. And at the end of the window, that's the start point. But those values seem to completely normal. Let's try to get through this. Finish. Step. Finish. It looks like a no, solve still. Vector. Solve. Inkeren objet verder solve. Which solve? Oh, I still have to enter it. See if a line 1, 2, 2, I still have to do step. Finish, step. Finish, step. Vector constructor. What is this? This is the new solve. So the value should be pretty sane then. So we have T0 and T6, and then these should be sane. They're totally not sane. They look like dots. Yeah, saw that one before. P3 and P6. Yeah, those three values we already saw before. And then the Chebyshev magic happens. Static, that's const expressions. Vector, yeah, we calculate 6 vectors in total. It has to be initialized. Values to coefficients. Very small. Hmm. Tolerance is calculated from the height, and now we compare it with the X thingy. Okay, X. This is just going to be true all the time anyway. Apparently we did not get the right tolerance vertically. This will be more than 10 times better. Yeah, this is nonsense. Or no, it's not really nonsense. Well, the value is nonsense. You can't 200 times divide something by 2. That's nonsense. So I'm kind of interested in what that tolerance does at the moment. I go one deeper. Even worse. There's no depth here. Depth of 1, another y. The res ID is not 0.06 but 0.09. It got it worse even. Why? And that goes up again. It's never gonna be 1/10 of this. Never. So I need to uncomment this to see what is happening. So the tolerance is never reached, therefore we never put anything in result. Oh, this is just nonsense. It was like that. Let's be smart. I think I want to remember the best tolerance, and then if let's say the depth increases 3 times even, and what the tolerance is not improved, then we just stop already. And then just use the values of the best tolerance instead of stopping when we reach a certain tolerance. I think this test is more like assuming that the larger the depth, so the more recursive, the more often we call solve recursively, that the more accurate it gets. Just more and more accurate, and more accurate. And then when do you stop? Well, it doesn't have to be more accurate than that. So we might as well stop. But if it just doesn't get more accurate, despite calling solve, then yeah, we need to stop as well. So I'm also not happy that I'm comparing the Y tolerance with the X value here, which is just nonsense. We need 2 tolerances. Let's have a Y tolerance and an X tolerance. The tolerance is not changed. X and Y. Let's make it a const because it's not changed, not being changed. The rest is const too. Okay, so well, I change the interface here. That's the Bezier filter solve. Bloop. This one, the private one. The white ones. And this is being called where. Well, it was called here, but also here. So we need an X and Y tolerance here as well. No, I guess so. Okay, now I can relax this a lot, I think. I mean, definitely. Let's say 20 times more relaxed. Need to change this signature. Solve function domain viewport. That is this one. Which has defaults. Yeah, I'm not sure that makes much sense, but yep. Hello, Joe. Probably all of them, right? I'm not sure though about the X thingy. Let's do this, but I'm gonna put the X at the end, so you can just leave that at -1 if you want. Yeah, that's it, I guess. And then I want to remember the best tolerance so far, which is could put it in Bezier filter. Maybe. Get this in there as well. So these things are const, right? I made those const. Why is the rest not const? This is my private function. What? I thought this was the signature of this one. The consts are magically not here and still it did compile. What the hell? Definitely the same function. I'm not getting it, but okay. Anyway, let's not pass these then. I'm just going to use member functions for those. I guess it's not part of the signature. If you add const for a function argument, then the signature doesn't change. And therefore you can declare it like this, with or without const, doesn't matter. Define it the way you want. Yeah, okay, it kind of makes sense. I mean, it doesn't make a difference, of course, if this is const or not. So just for the declaration, it's absolutely not interesting to see that these things are const. I'm actually going to change it back, so like this. Yeah. I just want to pass T0, T6, and these three. And then here, okay, I mean, yeah, well, you know, it makes the code maybe a tiny little bit more readable. You know that the function won't change these local variables. Yeah, but yeah, it's still interesting. I didn't know that was possible to have a different declaration and definition function signature in that respect. Now, what did I forget? I forgot to initialize these things, the member functions, before calling solve for the first time. So it would be this function here. So instead of passing them, I just assign these variables to the new member variables. And then don't pass them to the function. And well, since this is the first time, obviously the best one equals the first value. This is our entry point. So here they are initialized, and then we call solve for the first time, which then starts to recursively call itself here. And of course I want to update. Oh, wait a minute, the whole best thing is nonsense, damn it. I need to store this. I have no idea what the res ID means, because this is code I just stole from somewhere, I didn't write it. I wouldn't have an abbreviation like this in my code, nor this. In which case we need to initialize them with put a high value. Not like that. Something like that, and if not, then still x, y. Okay, so we call solve, and then where we calculate x and y res ID. Residue, I think. So, gets heavily improved here, and if it gets less than the demanded one, then we are done. Otherwise, we keep it again, call it again. You can reduce this 100 like drastically. Let's make it 48, 32 even, or something. $31. Don't need to test here. I mean, we'll just increment it, and then we will never increment it again. Actually, it is incremented. We just return, so that would be this solve. It's returning. Then we enter a solve again. Yeah, we don't even want that. So, okay. So, yeah. Well. Right. No, I still don't see it. Why am I testing here if depth is equal to 32? Oh, because you return without decrementing depth again. What? Why would I do that? Maybe I get it. So this makes it 32. It's larger than 32. Then we print this. And then we return, which might have been from this first function. So now depth is still equal to 32. And then we call this solve, which then increments it to 33, which is still larger, but we don't print it again. We just return. But yeah, that is decremented. It's not a very nice solution if you ask me. Okay, well, at the end here we return as well, which means that we return from these things. If you return for this one, it's like return, 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 return until we are getting here again. But the first one, yeah, that did recursively do something, and then in the end it returns. And then that might have been not decremented once. What is the result of that? That this second solve terminates earlier, one faster. Nah, I don't like it. Let's make it more logical. In fact, I could keep it simple and then simply enter this thing anyway and just use it when the depth is maximum. Let's try that. Seems more even easier to. Yeah, if that works, then I don't even need to track the best tolerance. My other idea was that if we reach this point, then I return, let's say, false instead of and return true here, and we are actually done. And return false here. And then if false is returned, then it looks if the best tolerance is equal to the current tolerance, and if so, then call this thing anyway. Again. I don't know. I'm gonna try this one first. Well, let's just try it first before I start deleting again what I just typed. Can I do a rerun or I think it should reload it. It was my last rerun. Okay, I should just rerun. 74, yeah, that was it. Point 30. Whoa. Still infinitely good. Depth. Hmm. I don't know. I'm just going to delete everything. Well, that seems to work because it's drawing it. And then it's no longer drawing it. Reach max depth ad infinitum. Now is that? It's an infinitely big vector. Apparently. What the hell happened? Is this my 31? Probably. 2 to the power 31. That's the size of my vector, probably. I'm having that feeling. I mean, if depth is 32, yeah, then we do 2 to the power 32 calls to solve. It's just still way too big. Way too big. Nobody knows where I edited that. Okay, there's a maximum number of calls I want to do. I have no clue. How about let's say 12? It's very random. But yes. Okay, now guess it's fixed good enough. It probably did print. Okay, it did print a lot because we have now 4096 Bezier curves or something like that. And each of those calls is a Cairo call. But hey, you can see it. Oh. What a mess. And it was erased, and then we got them on this without having drawn a new one. Let me see. This is the VI. Let's We're going to remove this search for the moment. I think we'll search somewhere else. Insanity check probably. And then the cubic might have been drawn already, which would be easier. Nope, it's not being drawn. But we are not crushing insanity check, but here, asserting, whatever. Assertion extreme type equals extreme type minimum field. Oh, right. Change type to right extreme. Maximum. Okay, a recap of what is the problem, what is happening. 19 is the right point of the cubic between 18 and 19, which is being used to detect this maximum here. That is, 18 is lower, and then we go up, 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 up. And we're still going up in 19. And then there is a maximum in 18. So in 18 it's horizontal. And after this point somewhere, I mean, I have no idea why, but here I do know why, but the exact value here is, I don't know. I think more or less random near 8. Everything is 0. So it's trying to find something that doesn't exist because the function is just discontinuous. Something somewhere between 19 and the last measured point, it just drops discontinuously to 0. So what it is trying to do is trying to cut the existing function into pieces that can be fitted with the cubic. So the cubic between these 2 points is just a horizontal straight line, and there's a horizontal straight line here. And here we have a cubic that is going up, does not have a reach maximum here, but it's pretty close to where that does reach a maximum. And now for some reason, I mean, we have added 28 here and 29 here, and this is number 30. And for some reason 31 is being added here. So in order to connect 31 and 30, we need a cubic that is horizontal here and horizontal here. So you get an S shape. It's like horizontal, and then yoing down, and then yoing horizontal again. Which means that the top here is the right part of a maximum, and the bottom here is the left part of a minimum. And I think it's detecting that as well. So now this is flat. I mean, this side is flat because it's a right max. Therefore, this side must also be flat. So that is being set to flat here. But it was up because I think it's still going up. At least here, 19 is just ending in up. Because it's a good question actually. Could have been flat as well. Yeah, I'm not sure what exactly happens, but I think that what you want to end up with is that this is, so 19 itself even is the left part of a maximum. So I just consider this flat. As you can see, it looks pretty damn flat. So you might as well say, okay, we go here and it's horizontal there, even though the actual maximum is there. And then if we add a point here, and this point is also seeing that it is flat here, that means that we get a cubic between 19 and 31 that is 100% flat. That is, it's flat on this side, and it is flat on, it's flat on this side, the left side of 19, and it is flat on the right side of 31. Therefore, it has to be flat on the right side of 19 and the left side of 31. And then there is a possibility that it makes a step of that, like so. But of course you shouldn't do that if the y coordinates are exactly the same, but they are not, because we know that it is going up and then reaches the maximum there. So this point is a little bit higher than that point as well. So maybe if you say, well, this is flat, you just call it stamp flat on it, then this is going to be turned into a step like this, which then turns this part into the right part of a minimum, while at the same time it's the left part of a maximum. So then it's not an extreme anymore, it's more like a saddle point. In other words, everything breaks down. That's what you see happening here. Now you can say, okay, but yeah, you shouldn't have a discontinuous function. That's the reason. But not so fast. You never know when you run into something like this in reality. So I don't think it should assert ever. It has to be able to deal with this in the correct way. The only thing that is acceptable to me is when it just never finishes. So it would say, make a sharper and sharper cubic, because it wants to try to fit a cubic that just, and then 90 degrees down, bang, there. And trying that, it makes steps closer and closer and closer and closer and closer, and then make this steeper and steeper and steeper and steeper until the cubic gives not a number. So you just get a floating point error because of the numbers get too big. That would be acceptable. Then I say, okay, yeah, well, that's the reason. The reason is that it is a discontinuous function. But this, the shape of the cubics logic should be able to deal with this, I think. I'm gonna close my windows, curtains. Sorry, be right back. Also, I'm going to stop streaming. For today, even, I think. Yeah, I'll be back tomorrow, okay? Good night.